So, good morning, everyone. Today we are merging two transformative technologies, FIWARE stack technology, uh, more precisely the context broker, and AI agents powered by large language models. Our goal is to turn complex NGS-ILD queries into natural conversations. You can think of it as giving your application a supercharged interoperability toolbox. I am David Campo, and over the next hour, we'll unpack how LLMs, MCP, and RAG technology can democratize access to contextual data. I promise no car commands required for now. So let's begin. Well, this is the proposed agenda for today's webinar. We'll start by diagnosing the pain points of traditional FIWARE workflows. This in the form of challenge and motivations. Then we'll introduce some technical concept, but in a high level, as such as LLMs, RAG technologies, fine-tuning, the MCP, the Model Context Protocol, a protocol proposed by Anthropic, which can be seen as the backbone of AI agents. Next, I will walk you through the implemented architecture, a short demo showing a live chat with a context broker, and finally explore future improvements and future works. All right, so learning goals. By the end of this session, I expect that you will be aware and understand the importance of reducing technical barriers through using AI. This is one of the main points of this webinar. Then we will understand what large language models are, why do we need them, what is RAG, what is fine-tuning, so some technical concepts, but the good thing is that we are seeing them as in a high level overview. Then understand what agents are and how we can use this model context protocol to implement them. And yeah, if there is one idea I want you to have after the webinar, is that natural language isn't just for humans anymore. Okay, so motivation and challenges. So imagine that we could interact with a FIWARE application, interact with the context broker using natural language queries like this one. For instance, asking which building is closest to the current location of Buttercup. This will be amazing instead of having this car command, which it hopefully does the same, but is a little bit more technical, more cumbersome, more we see the difference on the screen. Or we can just ask other questions like which animals are fed exclusively with grass and are in active reproductive state. Or we can ask for a task, notify me if there is any animal with abnormal heart rate, or other questions as well. Similarly, imagine that we have this answer back, something like asking for the location of an animal and receiving the building that are closest to that animal, instead of receiving something like this. I think the advantage is pretty obvious. But yeah, the question, why do we care about this? So why, and more importantly, why we invest energy on these kind of things? Well, I think that technology is evolving exponentially, not from now, but since decades before, or let's say since the beginning of technology. So we advocate for democratizing technical domains for a broader access. Currently, FIWARE system might require significant technical expertise for newcomers. So yeah, this way we can lower barriers, knowledge barriers, and facilitate onboarding and collaboration. Another point of this is that we can boost productivity and speed up different processes. So we can take advantage of this through rapid prototyping and scoping tasks, delegate automation to an agent instead of surveying everything. And obviously the experience will be much satisfying, and we can also enhance experimentation. This is accelerating iterative testing or focusing on domain-related queries instead of technicals. So these are some of the motivation of this. Now let's dig into more technical concept, but as I said, this will be very high level, so don't worry. We will define some LLMs, MCP, agents, and so on. So I think that yeah, everyone here knows what what LLMs are, but yeah, LLMs such as ChatGPT or Gemini from Google, Llama from Meta. These are AI models that are trained on massive datasets in order to generate human-like text-based output based on statistical probabilities. So they are highly versatile, but face some challenges that we will see afterwards. So I think this technology doesn't need any presentation, but just to you have an idea, this could be kind of complex. We are not digging on this, but is on the right we can see an image of one of the technologies that allow this. This is the transformer architecture published by Google in 2017. And this, along with the vast amount of data from internet and the computer power, enabled the rise of LLMs. So how do they work? Basically, they are this is a complex machinery that predicts the next token. For simplification here, we say that a token is a word, but is not precisely like this in the implementation in the real LLM. You can think of a token being like more or less 75% of a word. So in order to produce, let's say 100 words, you will use 125 tokens, more or less, just an heuristic. This machinery is based on statistical patterns. There is no true understanding on these machines. They don't understand precisely text. They are just sophisticated pattern recognition architecture, neural network. Yeah, we see language models that they can we can see them as predicting a machine that predicts the next token. Remember, for simplification, the next word here. Using the previous output. So yeah, so the previous the previous output of the LLM. So when the LLM receives, so it's kind of a recursive process. So when the LLM receives something like uh, this sentence, when the dog saw the thief, it has to choose the next token. Having this context and having this input is more likely that the output will be barked instead of pizza, which has nothing to do with the previous sentence. So they are producing this. So once the model ingests a sentence, it produces the next token, as we see here. It's completing the sentence based on probabilities. So this is actually the model doesn't build this tree of probabilities here, but you can see as the a tree living in a latent space. So the searching space of the model could be seen as a tree of possibilities, where yeah, you can play with what is called the temperature of the model. So when you lower your temperature, you will have more deterministic results. When you increase your temperature, you will have more stochastic results, having more diversity among different outputs of the same input. Yeah, so, but if this is what it implicitly builds the LLM, what's the difference between this tree and this one? So instead of creating English phrase, we can create a query, an NGSI query on anything. So it's based on the same principle. We can use this in order to achieve what we want, which is building queries for the context broker. So yeah, quickly, advantages. This is of the LLMs. This is versatile. We can write, translate, debug code, do a lot of things. They might be context aware. We can give some information that yeah, can be used for the output. But there are some challenges, as we previously said, that there could be hallucinations. This is generating plausible but false information. This is something that it seems that is real, but actually is not real. It can introduce bias, reflecting, shifting the data underlying probabilistic representation into different ideas or concepts. They are quite resource heavy. They require a huge amount of not only data but computational power. They fall short quickly in terms of obsolescence. So they are normally, when they are trained, they are frozen into a state with the trained information. So things that happen afterwards are no longer taken into account, obviously. They might lack of expertise on some areas. So they might be good for, let's say, producing some, I don't know, creating paragraph or creating poems, but very bad creating, I don't know, NGSI queries, for instance, let's say. On the right, we see one case of information obsolescence where we this image corresponds to 2024. It was asked, and I think in August or September last year, and asked about how many gold medals did Spain win in Paris 2024 for the Olympic Games, and it simply says that it doesn't have this information. So and it according to the last information of the LLM, this haven't happened yet. So yeah, this is one of the problems that we want overcome using this technology. So in order to solve some of the challenges, there are techniques for this retrieval augmented generation, RAG, that where basically the model receive extra information, context, external sources in order to answer question properly. And another powerful method is fine-tuning, which is basically retraining, let's say, a small part of your model with new data, so you can make the model more capable in certain domains. So what is this RAG technique? Is basically you can think of it as enhancing the LLM with external knowledge. We see a diagram here of how it works. So basically it combines different retrieval mechanisms with LLM to provide more accurate, contextually relevant information. So when a query is made by a user, a task, an agent, relevant data is fetched and combined with the query in order to generate a precise answer and also up-to-date answers. After we gain this contextual information along with the query, we pass this to the LLM, which will eventually build up the answer and return this to the user. For instance, a similar example. If I ask regarding our demo we are going to show afterwards about a smart farm, if we ask, in this case, as the DeepSeek, which building is closest to the current location of buttercup animal, with no prior knowledge, the LLM will say that I don't know what you are talking about, so give me more information. Give me at least the buttercup location, a list of nearby buildings. So with no context, the LLM cannot do anything. So instead, if we attach contextual information such as NGSILD entities of the object, the object we are representing here, and do again the query, the LLM is able to now provide an answer, a meaningful answer about the distances, the buildings that are close to this particular animal. So some considerations, some things to take into account. Typically, the information is when we perform RAG, is store this information in a vector database. So for speeding up calculation, gaining more granularity on the data as well. For this, we divide the information into chunks. So when the user makes a question, normally the most similar chunks, pieces of information regarding this question are retrieved from this vector database. And then, as explained before, the question plus the chunk are handed out to the LLM, and the LLM builds up the answer to give something meaningful to the user. But this is one option. It's quite a popular one, a good one, but it's not the only one. We can also use the context broker as a source of information directly. So retrieving the entities that are given by the context broker, we can have some advantages. So obviously, well, this will maintain the information up to date, because if we want to gain access to what the context broker has, the best idea is to ask to the context broker. We can avoid excessive processing, filtering by IDs or the relevant attributes, so we can select the piece of information we want. This allows us to build NGSI queries using the LLM according to this information, knowing the type of entities we have in the stored in the context broker, knowing the attributes of these entities. Furthermore, knowing the semantic context, knowing the smart data models used for the solution for your application, you can gain more background knowledge and build the queries in a better way. All right, so now digging into another concept, which is fine tuning. We mentioned this. This is another quality enabler technology. So practice, let's say, with fine tuning, we can adapt pre-trained LLMs to specialize in tasks or domain using, let's say, smaller but specific datasets. So this might improve the performance of some niche tasks. It requires less data for the retraining because we are training just a small part of the LLM. We are using the other background knowledge of the LLM, and we are training on a specific data set. Yeah, and also present some challenges. So it might be costly. This is we might require an array of GPUs or TPUs for performing this. If not done carefully, we risk of losing generalization by overfitting the provided dataset. Related with this, the data quality. So if garbage in, garbage out from the LLM. So we have to take care about this as well. Agents. So another concept, hot topic. Just a quick refresh. Agents are autonomous software entities that can perceive the environment, reason, learn, or basically act independently, enhancing the automation and reducing human intervention. For instance, a case of an agent could be something that notifies if there is an abnormal behavior of Buttercup, the animal. So the agent should be able to pick the right tool for this, or tool or set of tools. In this case, run the appropriate NGSILD query if necessary, and return the result, all without hard coding the workflow. This is the gain here. You can see this as like advanced DevOps for AI. Yeah. So how we can empower agents? Well, we can use what is lately the new kid in the block, a buzzword during the last month. The model context protocol, which was proposed by Anthropic, is an open standard that enables developers to build secure two-way connections between their data sources, some AI-powered tools. So this architecture, we see this image here from Anthropic documentation, is quite straightforward. Developers can either expose their data through MCP servers or build AI applications like MCP clients that connect to these servers provided by other developers. So some concepts here, so nomenclature. So we have MCP hosts. They are programs like, let's say, Cloud Desktop. This is the one I will use for the demo. IDAs, AI tools, or other agents that you wanna in any application you wanna use to have agentic behavior. MCP clients that they are protocol clients that maintain, let's say, one-on-one connection with servers. In this case, again, Cloud Desktop, the app I will use is this application already has the host and client integrated out of the box. It's everything in this application. NCP servers, they are lightweight programs that each one exposes a specific capability through the standardized protocol. Yeah, one case will be a server for exposing the context broker tools or performing some actions in the context broker. Then we have local and remote data sources that are I think this is self-explanatory, but it could be your file databases or an API on the cloud. So yeah, this is a little bit the fundamentals of working, the internal working of the MCP. This is a nice sequence diagram that I took from a LinkedIn post. I like it a lot, and it describes the interactions between MCP components. As we previously said, the MCP host client might be packed into the same app. This host and client could be, in my demo case, will be the chat application from Cloud Desktop. So the interaction is as follows. Yeah, first, MCP servers typically wrap existing APIs functionality that we can also, we can also include logic. We can cache data. We can transform data before answering. This is wrapped by the MCP servers. Then the MCP client interact with a single MCP server. But yeah, that is not necessarily the other way around. So MCP servers can handle multiple clients. The host, or in the demo case, the chatbot interacts with one or multiple clients, which in turn provide capabilities such as tools. For instance, could be get reservation, get entities, publish entities to the context broker, whatever. So it provides knowledge resources or predefined prompts as well. Could be the case. We will see a case of this afterwards. So the flow is that the MCP client fetch capabilities from the server, the MCP server, and register them as with the host application before they can be used. So when the user make a request, the host send it to the LLM, let's say the brain of the operation, along with the capabilities that were previously provided by the MCP client. So the LLM determines reasons about how to handle the request and whether to respond directly without any further intervention or requesting the need of a tool for more information. So if a tool is needed, the LLM instructs the host to execute it. Again, could be let's say get entities from the context broker. The host interacts with the relevant MCP client to call the tool. Before this execution tool, the MCP client present a request for approval to the user. We will see this in the demo, just to ensure the human oversight. Just this is currently for security reasons, but it's not strictly necessary and nor specified in the protocol. Once this is approved, the MCP client sends the request to the MCP server, which executes the function or the API calling. Then the MCP server returns the response from the client, to the client, which forwards it to the host. And then the host might decide if sending this answer directly to the user if no further processing is needed, or pass this partial answer back to the LLM for additional reasoning or formatting. So the final response then after this is sent to the user. Yeah, this is basically the flow of interaction. So it seems complex, but it's quite easy actually. It's quite simple actually. And yeah, this is a high-level overview of how things work internally. So let's get into the particular part of this proof of concept demonstration, the proposed architecture. So this is our architecture that integrates the FIWARE context broker with MCP enabled LLMs. So this setup allows for the dynamic querying and retrieval using natural language, as we saw at the very beginning. So simplifying the user interaction and yeah, improving capabilities and gaining more autonomous behavior. So in this case, the flow is that the user asks for a prompt or ask for a task to the agent, in this case, Cloud Desktop client, which run underlying using the underlying LLM technology. Could be the one provided by Anthropic, the LLM 3.7 Sonnet, 3.5 Haiku, or whatever it's the provider of this. And through the MCP protocol, which runs on a JSON RPC technology, ask for the servers. In this technology, we have installed 3 different servers. An MCP server for Neo4j databases, so we can interact with the Neo4j content. An MCP server connecting to the file system, so this allows us to create files, read files, dump some information to the persistent files, and one implemented by us, the MCP server context broker assistant, which expose the tools from the context broker. So how is this implemented? The context broker tools, for instance, here we see one example. For instance, this tool is called getEntityById. This is signaled by this wrapper here, MCP at mcp.tool. This instruct the protocol, the protocol that this is some functionality to be exposed by this server, and we simply achieve this task, which is given an entity ID. We perform the necessary request to the endpoint, where is the context broker. We return the information. Other MCP tools are, well, getting the version of the installed context broker, getting entity types, getting all entities, just a snapshot of what is holding the context broker. Well, this one getting the entity by ID, publish something to the context broker if we want to insert something, or performing a magic query context broker. And I explained this right after. So this magic query is, well, whenever other tools fall short for the required task, if they we cannot use them because they are not they cannot achieve the task goal, we can use this one, which is passing the natural language query to this function, which in turn asks a fine-tuning model that we train over the OpenAI model GPT-4o mini. So we instructed this model with some pair. We will see afterwards some pairs of natural intents in natural language and possible queries. And it tries to, given this query, build the correspondent NGSI query to execute against the context broker. So here we see, well, we put some instructions to give to this model. This is, well, the training model. We send the query and we get the response here. Yeah, and we return the response for the server. So this enables this last part here, which is basically the interaction with this when needed. The MCP server from the context broker will just call an API function on the cloud and execute this. If not, it will execute locally. So this is the extension on the architecture. So regarding, as said, we fine-tuned the OpenAI model. So the way we did this is just we instruct this LLM with a data set composed by more than 2,600 examples of this. As you see, we give the instruction how we want the model to act. We ask, we have an intent and a potential query result for that intent. So this is the way we pair this, as I said, in more than 2,600 queries. Considerations, these queries are all corresponding to getting data from the context broker. There are no training for, at the moment, obviously, for publish, push data, update data, no delete. We train on a small subset this possibility, so we are trying this and seeing how it works. For example, we are not training on temporal interfaces, just simple queries like getting an entity, getting one attribute of a specific entity, getting two attributes, three. We can filter by condition on these attributes. We can obtain different part of the information. So the idea is to capture and see how this can be trained to capture the structure of NGSI queries based on patterns in questions, in intents. So important thing is obviously without semantic will fail because the LLM has no way to guess the proper name or attribute of entities. So if I ask for the weight of an animal, without giving context, the LLM cannot know or understand that the attribute is called weight, and not otherwise, or that the animal is in fact an animal entity and not cow entity or cattle entity. So yeah, this is this solves a part of the problem, but yeah, basically for the syntax and the pattern of the NGSI query, it gives good performance. Well, this is an image of more of what I said. So you just upload. You go to OpenAI, select your model, you upload your data set in the proper way. You have this profile for the training loss. Yeah, once it's finished, it will give you the fine-tuned model. So yeah, now we will go with the demo. Just to know this demo is about a smart farm app with some animal entities. We have pig, cows, we have buildings, person, location, agri-parcels, and relationships among them, obviously along with the attributes. For instance, cows have weight, they have an owner, which is a relationship to person, entity, location, and so on. You get the idea. So on the right, we see a simple app showing some information about this. Just is for supporting and understanding how it works, but this is not used by the LLM nor the agent. Well, I don't know if you can see this graph, but basically is depicts the relationships. It's just an overview of relationship among different nodes. We have the animals, Bumble, Beanie, Diamond, well, different animals. They are from the cattle species. They are. This is yeah. They are cows. This is Beanie is the only bull of this data set, and we have here isolated nodes. The pigs. It happens that they don't have any information, any meaningful relationships loaded into the system, so that's why they are isolated there. Yeah, we see some relationships, like for instance, Tulip was fed with grass. I don't know, Sun is owned by the person too. Bumble was sired by Beanie. Calf by Trotter, I think it says there. So yeah, we depict the relationships among nodes here. So for the demo, I will interact with the Cloud Desktop application. I can ask some things like I don't know, asking the version of the context broker to get information out of it, list entity types. I don't know, ask for something of a particular animal, list the weight of, or list the animal that weight less than 50 kilograms. I can ask also to perform action with other MCP servers, not only interacting with the context broker, but interacting with the server that installed for this purpose, which is the Neo4j server, to create a knowledge graph similar to this one. See the interface of Cloud. We see here an icon saying that a hammer with a 20 here. This represents the different tools that are different servers installed in this instance of Cloud. As we see here, we have something related with the context broker, manipulating the file system, getting entities from the context broker, creating a Neo4j schema. Yeah, this is the tool set that the agent, in this case Cloud, can use. So one thing we can ask is there any running context broker you can access to? So we will see what it does. Normally, it will figure out that it needs to execute the context broker version to see if it can ping a context broker, and is asking for permission to execute this. So I grant the permission. It comes back with some information. Well, now here it tries to understand what is running and what is the information on the context broker. So it's getting the entities and the entity types. So it gives not only the information about our running context broker, saying, yeah, the version is this one, Orion LD version 1.8. It was running for 2 days and 19 hours. But also, honestly, I think this is because it learned from what I was trying and testing before, but that it went one step further and asked for entity types Yeah, and it's saying, okay, we have agri-parcel types, we have animals pointed in the context broker, building, person. So yeah, it made more than I was asked, which is it might be a caveat. Is, is, so we can start in asking. So can you, for instance, give information about an animal, anyone, any animal? This will execute a proper query. So it will retrieve information from cows, get entity ID. So it asks permission for executing this. It will ask permission for cow 001, which you will see is not precisely a cow, but is the bull. So it's Bini is a male. It weighs 690 kilograms. The legal ID is this bull 1001 Bini. The hair rate of the bull is 54. The diet, well, some information as I requested. Then I can ask something for filtering. Could you please list animals weighing less than I don't know, 50 kilograms, let's say. So it will perform a query, and hopefully we will get the information back. Okay, asking about find animal with weight less than 50 kilograms. It says that it found two animals weighing less than 50 kilograms. Blossom is a dairy cattle with weighing 30 kilograms, and Buttercup weighing 20 kilograms. One thing to take into account here is this part. I executed the query. Here, the LLM figure out that it cannot do this with the, let's say, hard-coded question API access as get entity type or get entity ID or other queries. So it asking permission for magic query context broker, which is the one I previously mentioned, that it sends the original query to the fine-tuned model and hosted in OpenAI, and builds the the query, the precise query, which is this one, asking for entities type animal with the filter weight less than 50. Then, well, this is parsed by the Python server, and is converted. The curl is because we train with curl commands, so it's converted to a request from Python, send, and after sent to the context broker, and we have this information back. So yeah, for connecting to another just let me show you. Let me see if I can show you something. Local. Well, this one is the is an app running locally just to inspect the animals. So we have Bini here. Is the bull weighing 690 kilograms. We have Blossom weighing 30 kilograms, Buttercup 20 kilograms. So the information is quite, let's say, accurate. And then we can ask this to interact with another MCP server. For instance, create a knowledge graph using the entities from the context broker. Say using Neo4j and Cypher language. I think this is an overkill language. and insert this into a database. So ideally, it will retrieve like a screenshot or a snapshot, let's say, of the context broker, and run different queries in order to create the graph database. This will take a while, but I can show you locally what is the local host. The result of this, it will create something like this, basically, which is yeah. Yeah, we have here the different nodes, entities, sorry, pointed in the context broker, and it created some relationships like yeah. Wow, this is nice. Here we see that Vinny is the father of Buttercup. Somehow we change the name of the relationship and the sense during the direction, because what is stored in the database, in the context, pointed in the context broker, is that Buttercup was sired by Vinny, which is actually is here. So we put both relationships. It's quite redundant, some sort of redundancy here, but okay. For now, it doesn't hurt. The same happened with mother and called by, but we have other relationship that yeah, the relationships are duplicated. The old McDonald owns Trotter, but Trotter is owned by the old McDonald. Trotter is located at East Pasture, which is located in, yeah, East Pasture. Also Tulip is located here. I think that we can specify more. My request was quite vague, so we can specify which kind of relationships we want to see in the graph. But yeah, this is more or less the demo I wanted to show you. So yeah, some thought about the on improvements and future work. So yeah, future enhancement include deploying LLMs locally. So for instance, using Olama instead of using Claude for processing and organizing all the sequences. We can use something locally. Then we can extend server capabilities. Remember that this was only tested using get queries, like get information out of the content broker, but we can go one step further and update entities. We can publish information, delete information, entities, attributes. Definitely, we should improve the RAG context using some embeddings for chunk of data. We did this just using the NGSILD entities, the raw entities, but we can improve this. This semantic support will be a nice to have following, more having more context about maybe following smart data model links definitions, and this way having more idea of attributes, names, and types used by entities in the context broker instead of heavily retrieving all the data from the context broker. Obviously having more integration, exploring other useful MCP servers as well. So instead of using just these two integrations, context broker and the Neo4j, we can use other tools that might be useful. So we have a lot of work ahead. So in summary, we have explored several concepts, but mainly the integration of LLM with FIWARE technology in order the goal to facilitate intuitive and efficient interactions. We leverage RAG technique and fine-tuning and also MCPs to create this some sort of framework that, yeah, I think that significantly lower technical barriers for newcomers, boost the potential of FIWARE solutions. So I leave you some resources related with this, but this is the links for the repository, the server, some more video demos if you want to see more, documentation and some quite technical reference papers for LLM, RAG, fine-tuning, yeah, the transformer technology presented by Google that enabled this LLM technology. So if you are eager for more information, this is the place to start. So thank you. Feel free to contact me directly if you want for deeper discussions or collaboration opportunities. So you can scan this QR code for my LinkedIn profile or drop me a message on my professional email address. Yeah, and I look forward for your question. But before that, don't forget to grab your FIWARE Global Summit ticket. If you want to see more about this and other technical training and talks about FIWARE, I think a good place is the summit in Rabat, Morocco this year. So yeah, grab your tickets. Thank you.